Hi, my name is Sarah Bourgeois, and in this video, I'm going to talk about the archived public lecture I watched called 10 Years of Southern Stargazing, How Star Trek Changed Everything, presented by Glenn Burns, the chief meteorologist at WSB-TV. This lecture was originally part of Georgia Tech's celebration of a decade of public outreach at the GT Observatory. Even though it was recorded back in 2017, the main idea still feels relevant today. How the premiere of Star Trek in 1966 expanded the public's imagination far beyond the Apollo missions and helped inspire generations of astronomers by blending real physics with speculative science fiction. One of the things I learned that I didn't know before was how strongly Star Trek influenced actual scientists. I always knew the show was culturally important, but I didn't realize how many astronomers and engineers credit it as the moment they first started thinking about galaxies, exoplanets, and alien life. Burns emphasized that while NASA was focused on reaching the moon, Star Trek was already pushing people to imagine faster-than-light travel and interstellar exploration. I also learned more about Burns himself. He's been with WSB-TV since 1981 and has won multiple awards for science communication, which helped me understand why he was chosen to give this talk. Some of what he discussed was already familiar to me. For example, I already knew that warp drive and transporters aren't physically possible with our current understanding of relativity, and that Star Trek often used real scientific terminology even when the underlying physics wasn't accurate. I also knew that science fiction often motivates real scientific progress, like how communicators inspired early flip phones, or how imagining exoplanets eventually led to missions like Kepler and TESS. But hearing Burns connect those ideas to astronomy outreach made the connection feel more concrete. The part of the lecture that really sparked my curiosity was the idea of faster-than-light travel. Burns mentioned it as one of the concepts that captured the public imagination, and that made me want to look deeper into the physics behind why faster-than-light travel is considered impossible under Einstein's relativity. After watching the lecture, I followed up by reading about the Alcubierre warp metric, a theoretical solution to general relativity that allows a warp bubble to contract space in front of a ship and expand it behind. Even though it requires negative energy densities that we don't know how to produce, it was fascinating to see how physicists have actually tried to formalize something inspired by science fiction. This topic also relates to my own area of study in physics and engineering. I'm used to thinking about forces, motion, and energy in a very grounded, real-world context, but this lecture reminded me that physics also has a creative side. It's not just equations, but also imagination and what could be possible. Burns' talk connected the public excitement around astronomy to the kind of physics we learn in class, like gravitational interactions, orbital mechanics, and the limitations imposed by the speed of light. It made me appreciate how science communication can shape the direction of scientific curiosity. Overall, watching this archived lecture helped me see how science fiction and real physics interact. I learned new historical context about how Star Trek influenced astronomy, revisited concepts I already knew, and followed up by exploring the physics of warp drive and relativity. Even though the lecture was recorded years ago, it was clear, engaging, and definitely expanded my perspective on how public outreach can inspire future scientists.